everybody. So my name is Shi, and today I'd like to spend 20 minutes just to talk about the privacy features in this icon. So how many of us actually recognize this icon? Oh, 50%. How many of us have actually studied crypto or cryptocurrency in the past? Okay, 30%. How many of us are working in IT? Nice, okay. 80% maybe. Okay, so just to make everybody on the same page, so we have two icons. One's Bitcoin, which is the first most successful cryptocurrency in the world. And after that, we had thousands of cryptocurrencies, including Monero. So today we're going to cover a little bit between these both two icons, and then we see what Monero does for the privacy parts. And both of these two cryptocurrencies, they are distributed systems, okay? And they are kind of digital currency, purely lives in the internet. And of course, they are kind of money systems, okay? Just like the euros or local currencies. It's just a money system. As a money system, we need to maintain a ledger. Ledger contains transaction information. Alice pays Bob, Bob pays Charlie, Charlie pays Alice. All this transaction information forms the ledger so that it allows us to understand who owns what and where in the system. It's the same thing in the banking system as well, right? But the banking system is somehow centralized. It keeps the ledger information highly secure because those transactions are customer information, the financial status. You don't want your salary to be exposed to everybody, right? So that's how banks' ledger works. But Bitcoin and Monero, they took a totally different route. They keep the ledger publicly available. Everybody has access to it. If you want to see it, you go to the internet and you can check those transaction information. What do I mean public ledger? Take an example. So this is the one Bitcoin account information. I went to a charity website. I copy-pasted their donation account. I go to the Bitcoin ledger. I get all this information. I can see this donation account has received more than 5,000 Bitcoins in the past, which as of today is millions of dollars. And they have already sent out majority of them out. I don't know where to be sent to. Maybe they have certain purpose. And also there are more than 100 transactions associated with this account in the past. There are senders or recipients inactive in this account. You can also see each individual transaction amount. So these things are financial status, right? Maybe for a charity, it's okay. They want it to be transparent, right? They want people to observe and monitor their organization. But what if it's a local merchant? What if it's K-Supermarket? What if it's a local shop, it's a Microsoft class? They don't want it to be transparent, right? So that's the privacy concerns of Bitcoins. People don't like that, at least most people don't. So Monero tries to handle these privacy concerns. It tries to protect the transaction recipients, the senders, the transaction amounts, and also the network information. We mentioned it's a digital currency. The transaction senders, recipients, they have IP address, they have routing information. Those are also sensitive data, right? It tells you who they are. So in the following slides, we just quickly go through these 4 points, and we see how Monero does the job. Okay, that's my talk. Not ending yet. So very basic knowledge, just to make sure everybody really understands what we're going to cover. So when we say in crypto, Alice owns an account. What does it really mean, owns an account? This key pair associated with this account, Alice really owns this little a red color. It's called private key. So that's the secret she keeps to herself. She does not reveal to anybody else. Who owns the private key? Who owns the money? It's simple as that. And she would give out this public key to the public. Everybody can transfer the money to this public key. That's like a account address, right? If I want to pay you, you give me your public key, and I transfer certain money to you. That's what you will receive. And the kind of magic here is that from the public key, there's no way, basically, to derive and get your private key. That's why we're so confident to give out a public key. It's kind of magic, but cryptographers did it. Okay, so these are the basic knowledge. Now, we start to get the ball rolling. The first part is protect the recipient. How does Monero protect recipients? It uses a concept called stealth address. The name doesn't tell anything at all. But we go back to Bitcoin. In Bitcoin, if Alice wants to pay Bob, Bob has the associated key pairs. Alice says, okay, what is Bob's public address? Big B, which is public information. And Alice gets that, okay, now I transfer the money to you directly. That's how Bitcoin works. As simple as that. But Monero takes a totally different direction. What it does is, Alice, come on Alice, Alice creates a new account. A one-time, fresh new account. This new account has a P key pair associated with it. And then under the hood, what Alice really does is that Alice, based on the big P, the Bob's public key, to somehow calculate and get the big P. Then Bob could confidently say that, okay, Alice did your job, now I can use my private key to derive the private key. So who owns the private key? Bob owns. So Bob owns this fresh new created account. Because it's a new account, there was no transaction information at all. When you go to the internet, go to the ledger, you didn't see anything, right? You just see, it's really kind of an interesting thing when I first time see it. When you check the transaction in Monero, all the senders, they just create a new account, send the amount there, create a new account, send the amount there. You don't know who receives it, okay? There's no way, technically, to link the receiver with this new account, which we call it a stealth address. It's a mysterious address. That's how it works in Monero. That protects Bob. A little bit details we can go through since most of us are in IT. Again, same story. Alice pays Bob. In Monero, instead of just one key pair, Bob has two key pairs. Why do we have two key pairs? We're going to just cover it shortly. Now just assume it uses two key pairs. And then Alice needs to generate this new account's public key. What does Alice do? Alice will create a new key pair, one time, fresh new key pair, just for this transaction purpose. After that, she will never use it anymore. So with this R key pair, she would follow this expression on the screen, get the Bob's public V key and S key and her own little r, follow the expression to get the big P. That's it. Nobody else can guess it out because the little r was the secret. Nobody knows it, right? Only Alice knows it. And then now the second step, Bob needs to verify, right? Does Alice really do the good job that she wants? There's a Diffie-Hellman. Many people working in IT knows it. And Bob somehow used the Diffie-Hellman protocol to verify Alice really created the big P as he expected. You can verify that once the P value matches to Alice's P, okay, Alice, you're done. You did the job that I wanted. So now I can use this Diffie-Hellman protocol expression to go to the third step to get my little p, which is the private key. It's not that much mathematics. Afterwards, when I really check what these things does, is that the little p, once you need the little p, you need the little v and the little s. Who has little v and little s? Apparently only Bob has. So only Bob has it, Alice doesn't have it, nobody else has it. So Bob owns the private key Bob owns this new stealth address. Again, Alice did all the job. Credit account, send the money, and Bob just sit there. Okay, I have my key. That's it. Nobody can see what's going on. So these are the story. The slides I think will be shared afterwards. So if you really want to see why it's like this, you can check it later. So we have some, I think one thing I didn't mention is why Bob has the 2 keys. I think it's also interesting. So when Bob opens his wallet, the wallet will check all this big P, all the stealth address in the ledger. What stealth address belongs to me? What stealth address belongs to me? Because of all the stealth address and collect all his own accounts, that's the big P's purpose. And Bob only needs the little v to calculate and see the amount of money he owes. And what if Bob wants to pay out, send out the transaction? He needs to use the little p. The little p has little v and little s. That's a separation of concerns. Okay? If I just want to see my money, I use 1 key. That's it. If I want to see transaction, I do need to use both keys. This is totally different from Bitcoin. Bitcoin has only 1 key. If you lose it, you lose everything. That's why 2 keys is better than 1 key. You can have 3 keys if you want. And okay, we have protected the Bob. How about Alice? Alice isn't happy, right, in the transaction. We want to protect Alice as well. So how do we protect Alice? Again, Bitcoin does the job like this. It's a very simple signature scheme. Basically, we use everywhere. Alice uses her private key, little a, to sign the signature, sign the message when the transaction happens. And everybody else could use her public key to say, was it really from Alice? Verify that. That's how Bitcoin works. Again, Monero did things differently. It's called the ring signature. The name, again, doesn't tell anything at all. Ring signature. What Alice really does here is that Alice will fetch somebody else's public key from the ledger, because everybody is quite open to send the public key to the ledger, so you can fetch as many as you want. In this case, just for the simplicity purpose, we say Alice just get Carol's key. And somehow Alice will sign the message and form a signature. The text goes like this. Alice has her own A key pair, and she gets the C public key from Carol, and she has the message, right? That's the prerequisite. And then Alice somehow constructed a signature which contains the 3 values in the second sentence. And then somebody else needs to verify it. How do people verify? It's basically 2 steps. I'll hide most of the mathematical calculation here. What we need to see is that from the 2 value of the signature, which is SO and CO, we can derive C1. And then we use the C1 and the S1 from the signature, we can get C0. What the heck is this? What does it really mean? It's a ring. You start from CO related information, which is the first step. You calculate to get the C1, and you use the C1 as input to the second step. And then somehow the C0 equals 0. So it goes back. It's like back and forth, back and forth, back and forth. That's the ring. You can play this game forever if you want. But that's the ring. Once the verifier says, okay, we can prove it is a ring, then what we actually proved is that somebody among these guys has used the private key to sign the signature. I don't know whose, but one guy. In this case, it's Alice, but I don't know. It could be Carol. Carol can form the same signature as well, and then form a ring. In Monero, typically people use like 5 public keys to hide himself, then that's a really difficult situation. Basically, no way for people to see, to understand and track a really detailed transaction. That's the ring signature. There are some details about how Alice created the signature, but we're not going to go through here. All right, we protect Alice, we protect Bob. Something else still for us to protect. Where the transaction amount, that's still like an attacking surface, right? If I pay you 1,000 Monero, I don't want that information there, right? So we need to protect the transaction amount. So in Monero, the transaction amount was already encrypted with a symmetric key, which was previously we mentioned the DPL. So basically, Alice and Bob knows this key, nobody else knows. They encrypted it. Afterwards, if Alice wanted to prove she really transferred this certain amount, she could hold the key and say, okay, let's prove that. Bob can do the same thing. But in crypto, the thing is that when the transaction happens, somebody else needs to take the transaction, verify that, and put it into the public ledger. That's the verification. Somebody else needs to do that. In Bitcoin and Monero, it's called miner. Those miners will use the computing power to verify that. But they don't really need to know how much input, how much output, how much transaction fee happens in that. They only need to see you kept the balance. If I pay you $5, you don't receive $8. You just receive $5. Maybe there is a little bit transaction fee. As long as the balance is there, I'm happy. I don't care how much fee happens in the transaction. So that's the trick here. That's exactly how those cryptographers construct a function which does the following. The function somehow takes each of the values and as an input to the function, the output of the function also keeps the balance. That's a kind of magic. As long as I can see, okay, the result keeps the balance, each individual input also keeps the balance. We don't have time to talk about the details why that happens, but it's the thing called the Peterson hash function. We know hash function is a perfect hiding. So from the output, there's no way to know the input. So the input is a transaction information. You can't know that. But the verifier, they say, okay, I verify the function, it equals 0, then the transaction information equals 0. So finally, the network. Network is the easy part because most of us definitely know the Tor network, right? It's the network to hide you behind the black market. And Monero does very similar thing. It uses I2P, which is an open source project. It does the same purpose, but it has some extra feature. It's better for the internal traffic. If it's a money system, you use it, it goes faster than the Tor. And it's a packet switch. It works like the internet, the TCP/IP package. It's not a circuit switch, which the Tor is. It's like a phone network. With the communication established, that tunnel has to be there before the communication ends. So a packet switch is more flexible in a sense. Finally, it supports UDP, which Tor doesn't support. Well, it's better than nothing, at least for me. And this is a baked-in feature, right? Users don't need to pay attention to that, why it works like that, how should I use Tor, how should I hide my information, so we don't need. And the summary is that Bitcoin has a low privacy. Monero is like the highest privacy, almost hides everything while still leaves the ledger public accessible. There are thousands of cryptos sit in between. Why is that? Why people don't like privacy? Of course, as a user, I want everything to be kind of protected. But we are living in the real world. We have to apply to the regulations, the laws, and Monero is actively used by criminals at the moment, right? The drug dealers, the pornographers, they are using it to do the money laundering. We don't like that. But that's the story. That's my end of story. Any questions? Yes, please.
Thank you for the presentation. As you said that in Monero, the regulator is very unconvincing. On the legal side, on the regulator side, what is their mind or what they are doing on it?
You mean they're from the legal?
Yes, from the legal side. Then they know that, okay, it's being used by illegal hands and that
Okay.
sort of thing. So
Yeah.
what they are trying to regulate?
Yeah, the thing is that for crypto, like Bitcoin, Monero, basically at the moment there's no way to kill it because it's a full decentralized distributed system. It's like a ideal world. Nobody can really kill it. There's no master knowledge that you kill it and the whole system fails. Nobody can do that. You just need to somehow monitor it to see how much amount of transaction really happens, something like that. That's everything you can do at the moment. Of course, regulators, you can say, but people don't use that. But that's all. Sorry.
Yeah, I have many questions. Some of them we can take offline maybe. If we're going back to the payment procedure, like when there is this one-time proxy kind of wallet. Yeah, like when, for example, I want to send.
That's stealth address.
Huh?
Stealth.
Stealth address.
This.
Yeah.
Okay.
So, where is it stored? Like, so as far as I understood, you basically create this anonymous, like a stealth address.
Mm-hmm. Alice created.
Hmm?
Alice created, right? In this example.
Alice created, but Bob owns it.
Yeah, Bob owns it.
How?
Because, because somehow the S and the V is used. The S and the V is used. That somehow links to Bob's account when Alice creates the big P. And when Bob wants to verify that, if you know Diffie-Hellman, that RV equals VR. That's the mutual agreed secret between Alice and Bob. They don't need to communicate in advance, but that's it. They both have their own key, and they say they don't need to communicate. They just kind of agree that if you use this, I can use my key to verify it's the same value. And if you swap the RV with VR, it's the same expression, right? It's just the VR is changed. And in the next step, the big P equals little p multiplies the G, the standpoint in crypto. The big S equals little s multiplies big G. Then the both side has, big G, then reduce the G. That's the P.
Yeah, I'm a slow thinker. I mean, I will check it after.
Yeah, check it out.
I mean,
or we can.
I know what's the purpose.
Yeah, I was
of
crazy.
it.
But then when I see it's as simple as this.
I can understand how Bob can derive P and then kind of owns the private key, so he owns the account. But to know that there was a transaction made, a new account is created that I have access to, if I'm Bob, I have to basically check every new account that is being created to see if I own this.
Yes.
Yes, exactly. So that's how you get notified that
Yes.
transaction happened to you. Yeah. You don't get notified. You have to verify every single new.
Yes,
address.
as far as I know. I'm not the real user, but that's how it is.
Alice will in off-chain tell Bob that, hey, I made a transaction for you, check it out.
Yeah.
And then he crawls the chain, the last transactions, and then he verifies if he
So
has
is
access.
that's how it's happened. There's
That's
off-chain
how it is.
communication.
Yeah, I mean, or Alice can say, okay, in 3 days I'm going to make a transaction to you, and then Bob will check if there's any kind of account which has the money.
Or both just verifies every single account that's been created.
Exactly.
That's still needs no.
Yeah.
Is it, another question?
Yeah.
There's a difference between a private payments network and an anonymized payments network, and you might want a system that can actually issue receipts, because sometimes you actually do want other people to know that you paid for something.
Yes, that's, yeah. I mean, Monero just takes this privacy thing to a certain extreme. Just hide everything. I don't know why. They just maybe it's a cutting edge technology. They're happy with that, and people are using it. We don't even know in the future if it will survive or not. I don't know.
I think there are interesting primitives in which you can actually create a new account with multi-signatures, in which you can give access to X amount of people. And if you use proxy encryption, you can even change the signature on the fly. So not change the signature, but change the access to the signature. I don't know exactly how things work, but I like overview. But yeah, I think she says really well, which is like this takes it to an extreme in which you really want everything to be anonymous.
Yeah, it's just the feeling that actually having an anonymized system is much better than having a simply private one.
Well, it's people's position.
Hi,
Yeah.
one question. Thanks. Actually, let me start by thank you for the presentation because it was really quite insightful. But one question to build up on what you were discussing about Monero and in terms of the regulations about it and that it couldn't be taken down. But how is it the security and the privacy when someone puts money from Bitcoin to Monero the first time or wants to convert from Monero to something else? What are the security and privacy implications there? Can you actually see who did that?
Okay. At the moment, I think there's no kind of like a spontaneous way to transfer the value between different cryptocurrencies. So you have to go through, for example, exchanges, right?
Yes, but exactly there. So
Yeah,
when
so-
you are exchanging to Monero or from Monero, do you have visibility on who is doing that operation?
From Monero to Monero.
No. When you are
Okay.
trying to put money, I have $5 and use an exchange to put money to Monero or to take money from Monero.
Yeah. So
Do you have
now-
visibility there?
Okay, so at the moment, most of people would buy either Bitcoin or Ethereum, and then
Yes.
change it to Monero.
Which are fully public.
Yeah, that's then up to the exchange to either track you or not. So that's somehow beyond the old Monero.
Correct. But that's the point, because you say criminals use it, but
Yeah.
criminals, they need to spend the money somewhere, and they're not
Yeah.
going to spend Monero.
It's-
They need to
it's
spend
really
real
difficult
money.
to cash things out.
Yeah.
So yeah, that's the current.
Will you track them
situation.
like
I
that?
understand what- Yes.
You,
thanks.
you could buy it with cash from a dude around the corner, the black market, and the same way you could cash it out. You don't have to go through an exchange. You just have to find a guy that is willing to sell you Monero for cash in a dark corner.
Okay. But how do you know it's privacy? Like you don't know who has it. So.
I
But
think
yeah.
there are this kind of OCT market. People don't go to the exchange, so they use Telegram or something to really offline a large amount of money to do the transactions. It doesn't affect your like the crypto market price, but people are doing that. Thousands of the bitcoins.
Get local Bitcoin.
Yeah.
All right.
I'm sure there's local Monero.
We'll take one last question, if
Yeah.
anyone has another chance.
So, what do you think of the general governance? Governance. I mean, if you think of like, Bitcoin Core
Yeah.
developers, priests
Yeah.
in Bitcoin, so what are the priests in Monero? Who sort of holds the
Yeah, that's-
authority?
That's something I do.
You have project.
I didn't follow yet. I understand the development of Monero, they take a certain cut on the transactions. 1% or something. And that's like the treasure for them, for the long-term support. So those guys, they are a fortune already, so they just sit there to develop this for the whole life. So that's it.